what, 3 lessons ago, we looked at the water cycle, the hydrologic cycle, and that's where we saw this picture. I showed it to you, where we get water that's on the earth through evaporation or transpiration, goes up into the air, forms clouds, and then we get condensation. And then once we reach the point of condensation, we get this thing called precipitation. Precipitation is where we get that water coming back down to the earth. And so what we're going to do is we're kind of focus in on precipitation today, because it's that precipitation that that really contributes to a big part of our weather. Okay. So there are different forms of precipitation, and if you're like me, you kind of, a lot of these sort of just kind of run all together, but there are some very specific definitions to each of these types of precipitation, and so I want to take time to walk through that, and we'll do that. Okay. So first is rain, and this is the most common type of precipitation, right? Basically, that water that goes up into the air through transpiration and evaporation, condenses and forms clouds, and once it gets big enough and heavy enough, the liquid water drops from the clouds. And as what we're going to see, as we'll see towards the end of the lesson today, temperature has a big effect on what form the precipitation takes. And so we'll get down through a lot of these others here as we go along. But the next type is drizzle. Okay, and the key thing about drizzle is that that distinguishes it from rain is the size of the water droplets. Okay, drizzle usually forms in the stratus clouds. Remember last lesson when we looked at all the different kinds of clouds? Yeah. Well, and it consists of little tiny droplets of water. In fact, it's this, like I said, it's the size of the raindrops that distinguishes drizzle from rain. I know in my own brain, I used to think drizzle was just a slow falling rain. Well, drizzle actually has a clear definition. Okay, raindrops typically have a diameter of around 2 millimeters. Okay, well, drizzle drops, that sounds like a kind of candy, are less than half a millimeter. I don't know if any of you ever used a mechanical pencil. Typically, mechanical pencils come with pencil lead that's either 0.5 or 0.7 millimeters. And so, if you've used one of those that's a 0.5 millimeter, you know that that's pretty tiny. Okay, so it's that 0.5 millimeters is the size of the drops for drizzle. But what's interesting is because they are so small, the drizzle drops do not fall very quickly. They tend to sort of drift downwards, staying close together and evenly spaced. And a lot of times drizzle feels more like a fog, okay, that's just slowly coming down. But that's the distinction that we make between drizzle and rain. All right, I know some of you live in cold climates, and you get snow. Okay, snow starts out as they start out in cold clouds. Okay, there's warm clouds and cold clouds. And like I said, when I get to the end, I'll kind of bring it all together. I got a picture to show you where all this stuff fits together and the temperature and how it affects different things. But snow starts out in cold clouds. Okay, and they form ice crystals. And as those ice crystals fall from the clouds, they actually absorb more water. And then that water freezes, which makes the ice crystal bigger. Okay, and it forms. Now, what's interesting is the size of the snowflakes and the design depends a lot on the temperature. And what's interesting is when the temperature gets close to the freezing point of water, snowflakes can get very big. We get big, fluffy snowflakes. Okay? But when we fall down below that freezing temperature, the snowflakes tend to be small, very powdery. And if you're like me, snowflakes have always fascinated me. Maybe they fascinate you. But here's a quick little video that the BBC did on snowflake formation. So I'm going to share that with you.